This is just a very helpful review for types of decay. So the first type of decay is alpha decay. You can put these in any order you want. An alpha particle looks like a helium atom. A stands for our atomic mass. Atomic mass is going to decrease by 4. Z is our atomic number, decreased by 2. And N over Z, this is our neutron to proton ratio. Neutron to proton ratio. So we're losing protons and we're losing neutrons as well. But overall, our change in our neutron to proton ratio is going to go up because you have fewer of both. Next one, beta decay. So in a beta particle, this is where a neutron splits into a proton and an electron. So when that happens, there's no net change in the atomic mass, and our atomic number goes up by 1 because we just created a proton. So in this case, we have increased our proton, so we didn't change our number of neutrons, we increased the protons, so this ratio, you make the denominator larger, so the ratio goes down. Next one, gamma decay. The easiest way to say this is it goes from an excited state to something that is more stable, and it releases a high energy gamma particle. Gamma radiation, with the exception of technetium-99, generally we don't. It just occurs in context with some others. So since this is really just a high energy release, there's no change as far as that we're going to observe in mass and protons. Next, we have positron emission. In positron emission, this is where a proton breaks down. So your proton and positron. So a proton breaks down into a neutron and a positron. A positron is the antiparticle of an electron. So look here, no net change in mass, and we have decreased the number of protons. When you decrease the number of protons, you are going to lower the denominator, so the net effect is to go up. Electron capture. This is where an electron is captured by the nucleus and it mixes with a proton, so those two combine, and you get 1, 0, you create a neutron. So here we have breakdown of a neutron, breakdown of a proton, capture of an electron. So we have no net change in mass, but we are losing a proton. So again, the net effect of positron emission and electron capture is the same. You're going to decrease your protons by 1, which will raise your ratio.